Hello everyone, let's see if this is working. Yeah, so I'm back to Twitch, just because it feels a little friendlier in regards to streaming, having people join and everything. It's easier for people to find the stream and just browsing stuff, and then I can always upload the videos on YouTube manually, I feel. Anyways, trying stream elements, and obviously I wasted like, I don't know, more than an hour looking at things, trying to configure stuff and everything, completely pointless. Which time I could have spent just streaming, and ended up not setting up anything. Anyways, I want to continue what I was doing last time, so I was working. Sorry, I guess you're getting what's up sounds now. Shh. Okay. No, this is not what I was looking for. GitHub. I think as I am Tom, Haskell exercises. Okay. So I want to continue working on the exercises I was looking at last time. Exercises. GADT. No. 01. Sorry, I'm still very sleepy and a little slow in doing things. I hope this isn't too bad. At least not worse than usual. Okay. So I think I stopped here at 5 at the boxes thing. I can give a quick recap. So this is a very nice repo created by I am Tom, which has a series of exercises with extensions. And they cover obviously a lot of interesting topics about Haskell or functional programming in general. So the first one was about generic algebraic data types, which is basically a way to write a little differently or data types, and I guess that's not the objective. The point is being able to using existential types and adding constraints. So what this means is, if we go back here to the explanation file, we can see this is a list defined as a standard data type, and where is it? And here we have another kind of list, which is defined as a GADT, which, as we can see, has an existential data type, meaning that's here in the input, but it's not here in the output. So actually, we have no way to work with this type here, except for, in this case, using this show a constraint. So we can show these a's, but we can do anything else about it. So yeah, this data type is not super useful, but anyways, here types are shown as functions, which is actually the same thing as here, because this is a function counts, which takes an a list of a, and returns a list of a, and it's the same as we have. I'm sorry, I don't know if you see down here. So we have a counts, which takes an a list, and returns another list. So it's more or less the same thing. It's a little more verbose, but allows us to do more, obviously. Things that we're not able to do without GADTs. Okay, so I went through the exercises last time, so the first 5 or so, and we can try the 6th one. And hopefully I won't embarrass myself. Gonna put an excuse here immediately because I'm very sleepy. Everything is it's very hard for me today. I don't know why. Sorry, a second. Okay. Anyways, we can put this full screen, I guess. 6. We can even use our type parameters to keep track of the types inside an H list, which the H I think is for heterogeneous. There's a viewer. Hi. It's probably me. I don't know. YouTube counts myself as a viewer. I don't know if Twitch does so. Anyways. So, for example, this heterogeneous list contains no existentials. Yeah, okay, so we have an heterogeneous list of A elements. So you can either have an empty list, which uses unit as the type for A, or we can have obviously a list with elements, which has a head, a list tail, and returns an H list of head and tail. So here we have no existentials because head is the input, but it's also in the output. Yeah, I feel like maybe I should publish it. Can I write the message in the functional programming Slack so maybe someone joins? I don't know. Maybe not. Okay, so we have this list which with no existentials and we have no constraints. Yeah, I guess there's another reason to use GADTs because we're not able to write this with standard data types. So yeah, we have an example list, which is an heterogeneous list with the first element is a string, then we have an int, then we have a bool, and then the list ends. So h const Tom, h const 25, h const true, h nil. Makes sense. So write a head function for this h list type. This head function should be safe. You can use the type signature to tell GHC that you want need to pattern match on h nil. And therefore the return type shouldn't be wrapped in a maybe. Okay, this is interesting. So we can write yes, h head, which take an h list of some a, and then we have b, which you don't really care about. And this h head takes an h counts a something else and returns a. I get an error. Why am I getting an error? Oh. It's interesting. So we have, I'm looking at this example. So we have the type is all these nested tuples, which representing here we have an h list of a and then some other nested tuple. And then we can pattern match on these h counts, which has the first element and then the nested tuples. But somehow it doesn't like this. Why? Let's look at the error if it's helpful. Could not deduce head, which equals p0 from the context 80 head tail. H count is for all head tail. Head H list tail returns an H list head tail. Oh, yeah. I told you I'm sleepy. I'm very sleepy. Okay, this is a nice start. If I'm struggling here, the next ones will be very troublesome. Okay, we did it. We did the first part of exercise 6. Anyways, it's getting closer to lunchtime. I wasted way too much time trying to configure this stuff, and now I'm very late. I will at least do all these exercises at the very least, and then probably start the next one. I don't know. Okay. B, 6.b. Currently the tuples are nested. Yes, they are. Can you pattern match on something of type hlist, int, string, bool, nil? Which constructor would work? Isn't it? Oh, wait. This is tricky because this tuple is not nested. That's 4 elements. I'm usually working with an head and tail. Will this work? Let's try. Let's get help from the compiler. So it's always gonna be an h count. It can be an h nil with an head and a tail. So let's try this first. Let's see what happens. Cannot deduce head equals int. So this is not working, of course, but let's see why. From the context, int string bool equals head tail. I have an idea how this is what's happening here, honestly. Yeah, I think it's not possible because the constructor only makes a 2 tuple, and we have no way to make it for a tuple, right? So this, yeah, we can do this. We can't. I feel like we'll probably go through the solutions after I'm done with this and see what I got right and what I got wrong. That makes sense. Can you write a function that appends one h list to the end of another? What problems do you run into? Can we? I think we need dependent types to do this. Let's try. So we have let's see, we have an h append. I mean, I feel like I either have to be very specific types, Or otherwise I have no way to do this because I don't know if what's in this B. If it's an L, maybe I can pattern match. Okay, let's try. Let's see what happens. So we have an H list AB, an H list CD. This is getting awkward. H list EF. So for a start, we have no guarantee that these E and F are in any way related to this. I don't know. I don't know if there is a way. So I guess a way would be creating a bigger tuple, maybe, but we can do this because we only have a 2 tuples constructor. I don't know. This is a bit over my head. I'm gonna say no, but I'm not sure at all. Let's say no. Okay, 7. Here are 2 data types that may help. Empty and a branch, left, center, right. This is gonna get tricky. Using this and the outline for each list above, build a heterogeneous tree. None of the variables should be existential. Okay. So you can have an H empty, which is empty. And then we can have an H branch. Yes, which should probably, so we should have a left, center, and right. No. This is return H3. Empty, of course, because we have to return this type. So this takes left, center, right, and returns an H3 branch, left, center, right. I don't know. And this probably compiles. Yeah, we got no error. I'm not sure if it's usable, if it's the right way to do this. Let's see. Implement a function that deletes the left subtree. The type should be strong enough that GHC will do most of the work for you. Okay. Once you have it, try breaking the implementation. Does it type check? What does it mean with breaking the implementation? I don't know. Does it type check? If not, why not? Okay, let's start with the types. Let's hope the compiler will help us, and I also hope that this is correct. Because I'm not sure. Delete left. Which is gonna take an H3. Wait. These should be trees, their own, right? Because I should be able to do something like just random pseudocode now left, center, right. This should become something like empty, center, right. I think. So this is not correct. I feel like. Oh, maybe it's empty. Maybe it's like this. Sorry. Branch. Branch. Delete left. Okay, we got something. We got something here. Okay. Oh, come on. So let's look at the list too, because we already did some of the stuff. So we're pattern matching on H counts here, which takes a head and a tail. So we can pattern match on each branch, which has a left that we don't need, a center and a right. And we return each branch empty, center right. Ah, no, it doesn't like it. Why did not scope? Perhaps you meant H empty. Did I mean H empty? It makes no sense though. Yeah. Couldn't match type H3 empty with empty. Oh wait. Left and right have to be trees too, right? Yeah, with a capital T. Okay, cool. This one compiles. Not sure if it's the correct solution, but we'll check it later on. Okay. Implement EQ for H3s. Oh god. Know that you might have to write more than one to cover all possible H3s. You might also need an extension or two, so look for something flexible. So flexible instances, I guess. Let's see. Recursion is our friend here. You shouldn't need to add a constraint to the JDT. I'm gonna fail this so hard. I failed so hard on this. So you might have to write more than one. Is it telling me that I have to write more than one? Is it a trick hint? Maybe I need one for nils, for empties, and one for non-empty trees. Huh. Let's try first. Let's see what happens. Empty. This makes no sense at all. Right? Let's try writing a generic one first and see what happens. So we have a EQ3, H3, which takes an H3, takes another H3, and returns a bool. H3, let's see what. Okay, so we can have an, if we have H empty, then I guess it's true. Then we have, in this case, when it's false, H branch LCR, H branch LCR. And this could be L equals L, sorry, equals L, and G equals G, and R equals R. Could not deduce left one. I don't know how to call that squiggly thing. It means that the types should be analogous. Oh, sorry. I was answering to a message. Very sorry. From the context, A branch left, center, right. Do I have to do this? Capital T. Oh no. Yeah, of course there's no H3 constructor. Oh no. Yeah. And obviously I can keep on going down branches because otherwise, yeah. No, so this is wrong. This is wrong. So what? Okay, let's go one step at a time. I think C equals C quoted should come. No, it doesn't. Oh, they have to be the same type. EQA. Oh no. Okay, so I feel like I probably have to, and then I can't use this for nils anymore, right? Branch.
Think about that.
Yeah, this is inaccessible. And it should work now. Oh, come on. L equals L quoted, C equals C quoted, and right equals R quoted. So this is accessible. This is probably not needed. That's not working. Damn. Because L and R are in H3. I don't think I can do this, but I can try. Okay, and this is where I'm gonna ask me to add the constraint. Yeah, use flexible context. Non-type variable argument in the constraint. And it works. And I guess we need h empty h3, which takes h empty, returns bool, ouch. It's a little pointless. What is wrong? Yeah, h3 empty, 3 empty. Okay, it works. It works. So recursion is your friend here, yeah, because for the left and right equality checks is gonna be recursing, calling EQ. Oh wait, I'm not doing any recursion at all right here. Am I? Am I? Come on. Oh, maybe this is what I have to do. Instance AQ H3L EQC EQ H3R EQ H3 branch LCR where why I get an error? Okay. And now we can have an instance AQ H3 empty where use flexible instances. Okay, works. So I feel like this is the biggest strength of a type language, and in particular Haskell, which JC is amazing. It's that I honestly had no idea how to tackle this. It would have taken me like hours with trial and error. Maybe not hours, but a lot of time trial and error, some whole fencing and printing stuff to write this in a type language. Well, you could argue that the structure would have been simpler in a type of language. Maybe it doesn't even make sense. Anyways, the compiler helped me. Now I'm very confused because I did something wrong at first. So instead of writing an instance for a queue, I just wrote some functions. And this function compiles. But does it actually work? Because it's just calling this here. Standard equality instead of EQH3 on the left and right sides. So I'm very confused. Maybe we can move this. I really need it somewhere else. Let's open a query term. Yeah, much nicer. Okay, Haskell 01. Was it add? Oh, come on. Excersises. Okay. Let's try using EQ3 first. Can I do a equal 5? Okay. So let's H31, which can be an H branch. Yeah, okay. It's a little unpleasant to write this, but H branch something on the right now, hello, and H branch or something else. Let's keep the right empty to make it simpler. And this, I guess we can make H3 empty, 1, H3 empty. Doesn't work. It's H branch. Or no, sorry, H empty. H empty. H empty. H branch. Okay, we don't have a show instance, so we can print it. But so we have a left branch, which is just a nested branch with one node. Then we have an hello, and then we have an empty on the right side. So what happens if I can do h3 1 equals h3 1. Here we get true. What if I do eq h3 h3 1 h3 1? I get true. How is it working? I'm confused. Let's create another tree. H3 2. And now here we can put an H branch, H empty, false, H empty. Okay, H3 1 equals H3 2. 3 2. Okay, of course there are different types, so we can match them, but this is true. H3 2. Let's see, H3 1. Oh no, sorry. Okay, still got the error. I get through. Oh, wait. This is working now because I have this instance here. Right? H3 1. Oh yeah, so now it's not working. Okay, makes sense. Oh, hey! Nice to see you here. I spent a lot of time this morning trying to set up stream elements, how it's called, and all the overlays and everything, and then I gave up because there's no point. It's just want to focus on content for now. And then when that's a little better and get some viewers, I'll get a little better with the overlays and everything else, all the contour. Okay. So yeah, this obviously doesn't work. I mean, it compiles, but then we get a runtime error when we try to use it, which is a little unfortunate. I wish somehow the compiler would be smart enough to tell us that this is not possible to do. Which sadly it's not happening. So we still need to write some tests here and there when writing Haskell code. So we can comment this. I wrote here. Okay. Oh, you're right. It's probably small. Oh, you know why? Because I pulled my config from the repo from a Doom Emacs config, and I reset the font size to the one I use at work, which is unfortunate. And also this font, it's maybe a little too thin. Oh, sorry. Increase font size. Is it better now? I should change to like a bolder font for sure. Where is it? Yeah, I think the main issue is that it's way too thin. Oh, it's Yusefka actually. That's weird. Font, reload font, big font mode. That's interesting. Oh, okay, this is very big. I'm gonna try with a 22. I also want to change font. Real font, big font mode, decrease font size. I don't remember the name. Is it Haskell? Oh, it's not actually restarting though. Okay. Oh, it's one L only. Okay, thank you. Oh, come on. Why? No, it seems it's not installed, so. Well, I'll stick with Yusefka for now. I'll look for a better font next time. I feel like this is already better, probably. 01 exercises. Well, it looks much better to me now. If you can confirm, it looks as big as the right side terminal. You can do list fonts. Is it an Emacs command? List font sets. Yeah, okay, cool. Yeah, I have no idea how Doom does this. I can also do this probably. What was the command? Oh, inside. FC list. Grab ask. Yeah, I don't have it. Yeah, it's not installed. Anyways, it's working. Okay, can move to exercise 8. I think also the team is better because I had a Cario Lite before. Yeah, this team has much lighter, thinner font, which is not good. Is it solarized light? Okay. Implement the following GADT such that values of this type are a list of values alternating between the two types. So we have an alternating list, bool int. Okay. So we can definitely have an h nil, which we can probably define it as this for now. Let's see how it goes. And then we can have an a count, which takes a b, an a, return an a count of ab. Sorry, an alternating list, not an a count. I don't know why, but GADTs make it much harder for me to differentiate between types and kinds, and I always get mixed up. It's different syntax, probably. Yeah, it works. It works. So I'm not 100% sure it's correct, but it compiles for now. Type checks. Okay, implement the following functions. Get first. So we get an alternating list of A, B's, and we return a list of A's. Okay. And then we have a get second, so we have an alternating list of A, B's, and we return a list of B's. Okay, interesting. And then we have to write the full values. Write this one using the above two functions, and then write such that it only does a single pass over the list. Yeah, this is gonna be tricky. Let's start writing these ones. So our constructor exposes the... It looks like it's missing something. Is it? Oh god. Oh well, I'll figure it out when the compiler starts complaining or get errors on the console. We'll see. We'll see. So yeah, these are very cool. These are very cool. And to be honest, I already did this first exercise like a week ago, and I got most of them correctly, and then I forgot everything. So like I feel like doing them again, it's very useful. These are like weird concepts that if you're not used to using them daily, it's easy to forget how they work. At least for me. I'm getting older. When I was younger, I could remember everything immediately, and now it gets harder and harder. Okay, I feel like I want to start from this one because yeah, it's this repo here. It's from IamTom, which is a Slack user from the functionalprogramming Slack. Let's see if I can paste them here. I have no idea if... No. Wait, because I have no unified copy-paste. But I can paste them from here. Okay. Yeah. I discovered it when you mentioned it. Yeah, it's very cool. It should be more publicized because it's very interesting, and I can't wait to get to the later exercises, where things should get really weird and mind-bending. I also started reading Sandy McGuire's Thinking with Types book like a couple of months ago, which covers the same topics more or less, more in detail maybe, more like type level programming oriented obviously. The problem with this stuff is that I get it, I understand it, I get everything, and then I never use it and completely forget everything about it after a bit. Because honestly, unless you're writing libraries, this stuff, it's not really needed at all. I mean, I don't need it. I write production Haskell daily, and I don't have to write this stuff, so at least for what I use it. Anyways, I feel like we can start from the seconds, because this constructor that I wrote, which is probably wrong, starts from the second element. So we have a B. Oh wait. Yeah, there's something missing for sure. So this is wrong. This is probably or something like this. Yeah, it's very easy to abuse. So I spent like a lot of time trying to using type level programming to enforce the correctness of some of my stuff. Like I wanted to only work with like orders that had a specific state and everything, and then my function got very complicated and too much specific, and it's like it's not really worth it sometimes, unless you're writing a library, something very complex. So, well, let's see. So this looks better probably. So we can have like counts of B and rest, and this is can try with B and concat with get firsts, rest, because now we are working with A's. Oh wait. No, okay. Just want to check. Yeah, he already gave me the types signature, so I have to keep that one. So this is AB and returns alternating list BA. Okay. So let's do one step at a time. Doing too much at the same time can get tricky. Right? But I defined A counts by getting which takes the first element first, the second element first anyway. So I feel like this was correct. So we have an A counts, B rest. And we can write this as B get first rest. Can we write this as get seconds L? Does it work? No, obviously not. So let's see what the compilers tell us. Oh, you have an idea, but you won't spoil it. Yeah, thanks. I know. Usually this stuff is like, yeah, you get stuck on something and then you get the right solution and say, okay, that was very, very easy. Oh, we only want to get A's, obviously. So yeah, we can't use this because we're not trying to just get the list. We only get the list of the A's or B's. Yeah, it's easier. I mean, even when I have no viewer, it's like I feel like I get much number because I know that there's people that are watching me or might potentially watch me, so I get like little nervous, spotlight fear. I don't know how to call it in English. So this is obviously not working. So let's keep one step at a time, which I feel it's easier. And let's see if this compiles at first. It's not compiling. It's not compiling. I feel like there's probably an issue with the type I wrote here. Maybe I got it backwards. Because I have to return an alternative list AB at the end. So this takes an alternative list BA, and this takes an A. Okay. So let's start with this one. One small step at a time. Get firsts. A counts, A rest. And let's see if it is happy with this. Okay, no error. So at least we are on the right path. Which is obviously not the right thing to do, because we don't want just one A, but we want all of them. So this rest now is a flipped alternating list. So the first element is a B. So we want the second elements of this rest. Do we? So we can do... You can do this, probably. And so we have an A, which we don't really need. And I guess we can just get the first of the rest. Ah! Why is it complaining? Cannot construct the infinite type. A... I think get seconds is wrong. It's is it wrong? Oh yeah. It's wrong. So let's see. We have an alternating list of A and B's. So that means that we have accounts which the first element is an A. Oh, not. Oh yeah. Oh, come on. Oh yeah, it was actually very simple. I was already ready to go into like a very weird trip trying to figure the error, and while the error was actually super simple. So yeah, this compiles, now it's giving us an error because we're not matching on nils. So you can do this. So obviously if we have a nil, we can just return the empty list. And seconds of a nil, return an empty list. Which obviously when we write recursive functions, we also have to have a stop somewhere where recursive functions can stop, otherwise we run indefinitely forever, or we can give us errors or whatever. So yeah, sometimes I have to remember that I don't have to fight the compiler, because the compiler is our best friend. Does most of the work for us. We just have to go with the flow and what it's asking us. So this works. I feel like we might try it. So let's write an a list, which let's use the example one. So it can be an a counts true, a counts 1, a counts false, a counts 2, a nil, and then 1, 2, 3. Ah! So if I'm getting an error, I guess there's something wrong with the type, with my data types. Let's see, a counts true, a counts 1, a counts false, a counts 2, a nil. Yeah, so this, what's happening? Oh no. I don't know why, but after a bit, Windows gets back control. Yeah, it's wrong. Oh, this one you say? No, yeah, this one. I think this one should just be A, B. So after a while, I don't know why, but Windows gets back control of my window key. Okay. And then I can't use some combinations anymore. Yeah. I don't know how to do this. Now I can't use Windows J and K anymore. It's super annoying. Anyways, yeah, my first implementation was way too specific, so, and obviously it wasn't working. So we can try get first a list, true first, get second a list on 2. Yeah, it works. So yeah, again, the type checker is super useful, but it can't save us from everything. So this one type checked, but was actually usable. So maybe I would have written this, like, hey, I did a good job, and now I can move on, but otherwise, actually it wasn't working. So let's try C. I'd like to restore my window keys, but I have no idea why this is happening. I know, Vlad, if you know what's happening here, but like after a while, my Windows key combinations, and not all of them, just some, like Windows J, Windows K now don't work anymore. That's weird. Well, anyways, I can live with this for now. So default values. So that's A, which is a monoid, B, which is a monoid, takes an alternating list of A and B's, and return a tuple of A's and B's. Okay. Using the above two function, then write it such that it only does single pass over the list. Okay. So, if you have an A nil, I guess we can return empty. Okay. GHC likes this. Obviously, we're missing the the actual hard part of this implementation. But so now we want to full values. Of this. Oh yeah, I use the direct edit thing for Windows L and it works for me actually. So that works. It's just that I don't know what other key combination I hit. Maybe it's like holding the key for too long. Like for example, open all the Xbox overlays now, and now like some keys are not working for me anymore, which is super annoying, yeah. Okay, so we have we need to fold the values, and now we have this a counts, a rest. Yeah, I have to disable the accessibility features. I have to disable them for sure. They're super annoying. Okay, so we have an a counts of a and the rest. And we want to return a tuple, of course, with some stuff inside. So we get some hints, so try to use the above two functions. So yeah, of course. Yeah, we can probably do something like this. We have get first, we get second, so obviously it returns as list, so we can do this. And then just use mconcat, get first access, mconcat, get seconds access. This should work, right? Yeah, it works. So you can do this, you can do this, you can do full values, a list. Oh yeah, we can do this with this tree because bool is not monoid. Well, anyways, this works. Trust me. I'm pretty sure this works. The issue now is trying to do this in a single pass. I don't know if I'm able to do this. It's probably one of those mind-bending exercises. Because obviously right now we're doing two passes. We're doing a first pass to get the first elements, and then we're doing a second pass to get the second elements, which is not very efficient. So now this probably will have to be some kind of recursive stuff. So probably want to do to pattern match on the constructor. So we can have the first element, then the rest. And we want to do something with this. So let's go. We want to return a tuple. Yeah, I don't know. I don't think it's asking us to use the two functions to do it in a single pass. We'll see. I'll try to write it and see if I manage. Maybe I will have to use the two functions anyways. Who knows? Well, anyway, so I'm returning a tuple, and already have the x, which is the first element here. Oops. So I can for sure put this x here, which is gonna be appended to something, and then I need something else here. So this first step is easy. Found the OA, which sometimes GHC is able to give us interesting tips here. Sometimes they're useless, but let's see. So there's a hole, we just type A. Yeah, okay, thank you. A is a rigid type variable, bound by type signature for full values, blah blah. So relevant bindings include access, which is an alternating list, BAs. Yeah, it's not very useful. So obviously I could use get seconds and get first on the rest, but it would be completely pointless. I would get the same implementation I had before, right? So what I know is that by calling fold values on access actually gives, this is what I can use, right? Ah, this is so tricky. Let's ask JC. Let R equal full values success. Find type wildcard underscore standing for BA. Are B and A are rigid type variables bound by type signature, blah blah blah. So are these B and A's the actual B and A's we need? Let's see. So let's try BA. I get no error. Not entirely sure if this works. I feel like we really have to try. I need a new list because that one is not good enough. So we can use strings. I guess I can use a list for the next one. One. A counts B. A counts 2. Yeah. Anil. Let's close this. Okay. Yeah, let's see. Full values. A list. Let's see the magic happen. Yeah, it works. Okay, so I have to be honest. I'm not sure at all how this is working. It's working. It's another proof that GHC is much smarter than I am. So let's see. Full values list, go list, empty, so a bit more explicit. Oh, let's try that one too. Yeah, this is probably easier to reason about. Oh wait, but how do you know where do we have to append this way? Or maybe I didn't get what you're trying to do. But now this goes sometimes is an A. This X sometimes is an A. One time is an A, one time is an a B. So you already have a solution in mind. Yeah, let's say we have like okay, yeah. So now I'm at the first run, so I know it's the first run. I feel like probably we need two helpers that call each other recursively. I'm saying because now I have an X which I have no idea if it's an A or a B, so I don't know where I have to append it. So I probably have to do like go one. Which becomes go to access X A B. Then I go one A nil. And then I go to a cons X access. Yeah. Something like this, right? It's complaining. Why is it complaining? Couldn't match type B with A. Let's try adding some explicit signatures here. Couldn't deduce semigroup A1. Yeah. Do we need it here in full values? Do we need it in the recursive functions? And then I guess I need run types. No. It's still not working. Yeah, no, yeah, it's enough. But yeah, we can, maybe we can try using, as you say, flipping the pair every time. Let's see if it works. Oops. So, Maybe not. No, I feel like it's not working. So let's try keeping this simpler for now. If I don't append anything, does this compile? Oh, I actually need... Okay, let's try. I thought that rank and types included explicit for all. Oh, you... No, now I get like an error here. I need both? Oh, sorry. I still get this error. Couldn't match expected type B1 with actual type A1. Why is it expecting B1 here? This makes no sense. So go2 takes an alternating list, a tuple AB. But why would I need to flip the pairs? I mean, I'm passing the same pair and returning the same pair. The only thing that's flipping is the list. I mean, I'm not appending anything, so this is basically just threading through the original pair to the end. So this just return empty. Right? Oh, sorry. Oh, yeah, okay. Yeah, of course. Of course. Ah! It's always stuff like this. Always. Okay, well now we're back to the original error. Where it seems like, yeah, it's not treating these A's and B's as the same A's and B's we have above. And I think this is what this for all is supposed to do, right? Is our signature wrong for some reason? It compiles without the signature. No, I get no error here, so the casing is right. It's the signature which is wrong. Interesting. Let's see what GHC thinks the signature should be. It's the same exact signature I had. And what about go2? So I have no idea what's happening here. Because the signature is correct, but if I use it, restart Emacs. Wait, I can try this. I can save and reload here. No, GHC gives me an error too. So it's not Emacs. I don't know. It's probably some weird quirk of type level programming. I don't know. I have no idea. I don't know how to solve this. Anyway, so yeah, we got the solutions. I feel like I wouldn't be able to get to this one without GHC, which is giving us the solution more or less. Well, you know what to do. Just use the things you have, put it down, use type holes, and the compiler will do most of the works for you. So yeah, this one is much easier to reason about for humans, except that it's not working. I mean, it's working. I just have to do this. Yeah, it looks like black magic for sure. It's like creating matter from nothing. It's alchemy. I don't know. Yeah, I think we are able to do this only because Haskell is a lazy language. I feel like probably something like this in PureScript would explode. Anyways, let's comment this. Leave it here for posterity and get back our correct answer. Okay, 9. We're almost done. Here's the classic example of GADT, in which we build a simple expression language. Note that we use the type parameter to make sure that our expression is well formed. So we have data a, so we have an equals, which takes two expression of ints, and return expression of bool. Oh yeah, see you later. Maybe I will do a short break too. Maybe make a tea. It's getting very close to lunchtime. Since I don't have scenes, I'm gonna write it here.
Mic off. Mic on.
Okay, I'm back. Starting to get really hungry. So I'll try to get done with this so I can go cook some lunch. Okay, so implement the following function and marvel at the type checker. Okay, if you say so. So eval, which goes from xprov a to a. Okay, let's try. I'm gonna enable lambda case. Um, is this how it works? I don't remember. Yeah, okay, it works. Okay, so we are building our function which evals an expression tree. This is the default example when they teach you how to write a simple programming language. Anyway, so if we have an equals expression, we obviously want to check if they're equal, but we need to eval them too first. So we eval I, we eval j, and we equal the result. Yes. Then we have equals. Sorry. We have add ij, which is just eval I plus eval j. Then we have if b. Let's stick with ij for now. So we can do if eval b, then I, eval I, else eval j. Then we have int value I, which is just I, and bool value b, which is just b. This works. This is much easier if it's working, which I'm not entirely sure. Let's see. So let's write an expression here. Yeah, I'm pretty sure too, but sometimes I'm sure and then and then it's not working. So let's write an expression. So we can try like if equals int value 1, int value 1, add int value 1, int value else int value 5. Eval x1 returns 3. Yeah. What if we change this to 2? Will it work? Yeah, it works. Yeah, this was easy. At least after doing all the rest. I mean, and I'm much more comfortable with these kind of things. Worked a little on the pure script compiler, very minor things, and I'm writing a PHP backend for pure script in my spare time, which I'll probably stream about next times. So yeah, I got a little more familiar with this kind of representation. Here's an untyped expression language. Implement a parser from this into a well-typed language. Note that until we cover higher rank polymorphism, we have to fix the return type. Why do you think this is? Ha! I don't know. I'll answer after I'm done trying a little, working with this. Okay, so we have to go from our dirty expr to a maybe expr int. Why? Wait. Why is it int? Is this what he's asking us? Why can't it be like an exprov a? Oh, because there's no a here. So if we do this, I guess a is an existential. And there's no way for this to work. So yeah, the caller can't instantiate this a. So okay. We answered the question, now we just need to implement this. So we can have a dirty equals AB. Okay, this is weird. Yeah, of course, I'm missing. Let's start from the final values. So if we have a dirty bool value, yeah, if we have a dirty bool value b, I don't think we can return a just bool value b, right? Can we? Yes, of course not, because this is a bool and we have to return an int. So this is nothing. How is this gonna work? I have no clue, honestly. Yeah, of course. But then how will this parse? I mean, that's what's confusing me. Okay. Sorry, dirty int value I, and then this just can be a just int value I. Yeah. Okay. Oops. I think you need a sub parser for booleans, but it can be the top level parser, maybe. I don't know. Yeah, I'm very confused right now. So I mean, obviously you can do something like this, and it compiles. Well, it's probably not what's been asked for of us, right? Or maybe this is the correct solution. I don't know. Let's see if it's possible to work on the rest. So let's leave it like this for now. Let's try adding more cases. So what if we have a dirty equals of some expression and another expression? Yeah, this is not working, right? Because I can parse A, and this is a maybe X print. I can parse B, which is a maybe X print. But I can't turn it into an equals because it will be an X per bool, right? I mean, I can do something like this. And this is bool, so I can do this. I'm starting to think that this is actually the only the only implementation. But, maybe we can do something with adding. Dirty add AB. Yeah, we can work with this, right? Okay, we can add stuff. We can return int value. We can add stuff. Can we use an if? I think not. I mean, we need a guarantee that we're returning an int value, right? Maybe we can. Let's try. I feel like we can only do this. Sorry, dirty bool value A. It's getting very messy. Because dirty if can contain anything, the first expression. But obviously makes sense only if it's a bool. Since it is not a GADT that can express that this has to be a bool. We can express it here. So it's correct only if the first one is a bool. So if A, then we can parse B, else we can parse C. Okay, we're missing equals, and equals can't return anything. We can't return any int with equals, and the same for bool. So I want to say that this is the correct solution. I don't know what you think, Vlad. What if I want to write if equals 1, 2, 3, 4? You're right. Yes, you're right. Oh no, wait, it can be equals. It can be if dirty equals, but then we don't have a way to evaluate dirty expressions actually. Okay, then we can do this. Oops. Yeah, it's not super pretty right now, but oh no, I don't think we can do this. Can we? We can do this because yeah, you're right. right. I'm just trying to go one step at a time and see what the problems could be. So dirty equals takes to dirty expr, but we have, yeah. So we need a we need the dirty eval, which we can't write because this goes from a dirty expr, and what's the result? Yeah, I feel like it's not really worth it. I think the point of this exercise was only to make us understand why GADTs are useful and why you can do this with standard data types. Because like matching this parse here, I think the only thing we can do is have two dirty evals. Something like this. And then use this one when we want to check for ifs. But yeah, I don't think it's really worth it. So I'll stick with this. Okay, now I'll just... Maybe you can just make an evaluator for dirty equals only. Yeah, I can. I mean, we can definitely get something out, but I don't know. I'm gonna cheat and look at this at the answer for this, because I'm curious to see. Oh wow. Okay. Okay, the solution is something that probably I'm not able to do on my own. Sorry. Yeah, there's also something very interesting that Tom does here with his unpill for the previous exercise. But so where are we? Okay, so this is a super tricky one. First, we need the GADT. That means we can pattern match, figure out the type of our expression. If we have an int type x, we know that x is x per int. Similarly for bool type. Okay. I mean, yeah, I understand the English of this sentence. I'm not sure I understand what's happening, why. Okay. Now we need to do some really grotty pattern matching to guarantee that our types line up. Typed gives us a way to figure out whether we have the right types, and so we can just start to put together an expression. The nice thing here is that it's pretty much guaranteed to work if it compiles, because of how strict the types are. Okay, so we have a tidy, which goes from a dirty expression to a maybe type. Okay, let's try writing this. I feel sometimes it's easier to type stuff. So this data typed, which is a GADT, which goes from an int type, which is one of our expressions. Sorry, which goes from an expression int to typed. Sorry, and then we have a bool type, which goes from an expression bool to typed. Okay, maybe we can learn something cool that I'll forget in a week or so. And then it defines a tidy function, which goes from a dirty expression to a maybe typed. Why is it maybe? It can be just typed. We'll see. Okay, so we want to tidy dirty equals. Oh man, this is gonna get recursive and weird. Let's start from the simple cases. So if I want to tidy a dirty int value x, okay, we're returning just int type int value x. Because untyped expressions can be ill-formed, it could try to add booleans or whatever. No. I mean, yeah, it's just hiding the return type, so it's not int or bool anymore. And then we can have a function that works with everything. I think that's the point. Okay. Then if we have a dirty equals xy, that's a case tidy x tidy epsilon. Oh, but it doesn't recursively go through the tree, so it only stops at the first level, right? Because equals only matches in, if there are two int types. Doesn't call tidy recursively. I wonder if it would be possible to do. Oh. Yeah, okay, makes sense now. So this does this for the equals, does this for the add, which only takes two int types. So I guess it's doing what we were thinking about, just in a cleaner way. And obviously, your example of equals 1 2 true wouldn't work because it's not recursive. Tidy p, tidy t, tidy f, off. We actually have two cases. Okay, yeah. Just bool type p, just int type t, just int type f. Well, I'm not gonna type everything. Get the idea. So there we have two cases for the dirty if. One where we have two int cases, one where we have two bool cases. And then it just runs tidy, and if it results in int type, it returns it. Otherwise, it's nothing. Yeah, so we can see the power of GADTs. Makes this much easier. While this dirty expression, it's much more verbose, and It's very unsafe. It's much easier to write wrong expressions than right ones. Well, that's not possible at all with the GADT, which is cool. Okay. Yeah, let's move the solution away. Can we add functions to our expert language? If not, why not? What other constructs will we need to add? Could we still avoid maybe in the eval expression? Wait, is it talking about the expert or the dirty expert? I don't know. Did I delete too much stuff? There's no maybe in the eval function. What is it talking about? We can steal functions from Haskell to achieve this sort of things. When we do so, it's called high order abstract syntax. Yeah, okay, no. I'm not go. I don't know. I have no idea what it's talking about. Or HOAS. It's the first time I hear about this thing. Higher order abstract syntax. This means we end up with a pretty little thing like... Okay, we had functions for expert. Okay, so we wanted to add a function here. I see. Yeah, okay, no, makes sense, yeah. Sorry, I misread the question. Still, yeah, know that we call higher order abstract syntax. Okay, 10. It's the last one, and then I can go have lunch. Back in the glory days when I wrote JavaScript, I could make a composition list like pipe fghij, and it would pass a value from left side of the list to the right. Yeah. Nightmares of trying to combine lambda functions in a pipe without a type checker. Very funny. In Haskell I can do that because the functionals all have to have the same type. Yeah, it's a shame. Is it? Fix that for me. Write a list that allows me to hold any functions as long as the input of one lines up with the output of the next. Okay. Okay. So the more okays I say, the more unsure about how to do this thing I am, obviously. So I feel like this is gonna be something similar to this. Which types are existential? Write a function to append type align list. This is almost certainly not as difficult as you initially think. You're overestimating me. So we have a type align list, A and B. So I guess A is the input and B is the output, right? I'm not sure if this is the correct direction. So we have... Let's see how it goes. Okay. And I guess this takes a function from A C takes a type align list. Oh, let's call it. Okay, type align list from C to B. And returns a type aligned list AB. Does this make sense? No type errors. Maybe we are on the right path. Who knows? Which types are existential? C is existential. The output of the function we're counting. Write a function to append type align lists. This is almost certainly not as difficult as you initially think. I don't know. I don't know. This feels very hard to me. Okay. So we have a type align list, another type align list. I want to return a type align list. Interesting. So can we work with nils here? Does this make sense to the compiler? Wait, I don't even get a warning. What's happening? Oh. Okay. So if we're composing two nils, we get a nil. It's the only thing we can get. If you're composing something with a nil, I don't think we can return the first list because the types don't align. So I think the only thing we can do is compose. So we have a function here and a rest. Another function here, another rest. This is gonna return something. And in all other cases, we can only return a nil list. Okay, the whole is type align list AC. Okay, so we have an F. Wasn't the relevant buildings supposed to be much longer? Okay, why isn't it telling me the types of F and G? Okay, let's try this. The result is gonna be a tal cons of something. So we have an F. What's F? Type of F is type that goes from B to some B1, right? And G goes from A to an A1. No, I'm overthinking this, come on. Right? So this goes from A to B. So I want to append at the end the first element of this one. Or I can go the other way, no. Okay, I'll go this way. B, and then recursively keep on appending the elements. This is tricky. So I can do this. So if I can do this, y has to be the first element because it's a function that goes from A to something else. So this is gonna be y for sure. Okay. I guess I have to keep on unpeeling this ys. Compose TLS ys, which is fine. The problem is that now I'm just basically replicating this list. So here, if I have an excess, does this work? Will it touch up? Type check? No, it doesn't. Oh, sorry. I need this. Interesting. Interesting, 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 interesting. So if I have an excess goes from B to C, another list goes from A to B. I keep on composing the second list. So I get back this A to B. Why is this not working? Can I match type B with A? Of course, because this is a B from B to C and one's A to C. This is almost certainly not as difficult as you initially think. I don't think so. maybe it's the type which that's wrong here. Very tired and hungry. I think I'm gonna look at a solution for this one. Oh, type align nil is type align list AA. It's from A to B, BC, AC. Okay, there are a few differences what I did. Of course, because nil has to be that entity. So this goes from A to A. Oh, that's it. This is it. The only thing I needed to change. Why? I have no idea how this works. What's this magic? Oh, because then nil is from A to A. So this becomes a type align list from A to A. And this magically becomes from A to C. I get the idea. Feels like little like dark magic. Yeah. Very weird. Very, very weird. I'll definitely get why this has to be AA. Because if there's an empty list, I can't transform the elements. What I get from the input has to be the output. But how this fixes this? What's actually happening? You know, this becomes an align list from A to A's, and this has to be an align list from A to C's. Makes sense. Don't know if I would be able to replicate it. Well, anyways, it's almost 3 p.m. here, and I still have to eat. So I'm gonna wrap it for now. And the first chapter is done. And how many more chapters do I have? Oh, there are 10 chapters. I think the second one is pretty short, if I remember correctly. And then from the third one on, it's uncharted territories. I have no idea what's inside of those chapters. I think they're very interesting. We have data kinds, kind signatures, rank kind types, type families, constraint kinds, polykinds. Yeah, you should. It's fun. It's fun. It's mind-bending. And having to do this on stream really forced me to work correctly, finding a solution, not cheating. So it's much better. Because if it would be on my own, it's like try 10 seconds, say, okay, no, I can do this, and then go check the solutions. So this is much better. Yeah, it is our mod. Well, thank you very much for watching. It was a pleasure. See you next time.